Okay, identities. Now, I did quite a few of these in class with you, and I gave you guys a chance to try these on your own, and I think everyone was doing relatively well. Everyone was doing relatively well. Sorry, dropped a pen. Let's continue. Anyway, we know from our identities we need to get our left hand side equal to our right hand side. We also know that even though we are going to prove that they are true, meaning left hand side and right hand side are equal, we don't know that yet. And because we don't know that yet, you cannot take things over or divide both sides by the same thing, stuff like that. You're not allowed to, okay? I've included a few of them very similar to the ones that we were doing in class. You generally work with the more complicated side. Sometimes you can work with both sides. Don't forget you are allowed to use any of your factorization rules in between here. You are allowed to multiply out of brackets. You are allowed to use your identities. You are allowed to use a reduction formula. You're allowed to use all of that, okay? As long as you keep each side separate, okay? The first one that we have, we need to prove this and this. The sine x plus cos x squared equals to the side over here. Right, I see the side is more complicated, so I'm going to bring it here. I see it's a bracket squared, which means that I can apply grade 8 and 9 knowledge of FOIL. This here gives me sine squared, this here gives me cos squared. Multiply the two of them and double it, it gives me that. I see sine squared x plus cos squared x, same angle, and they're squared. I know that's an identity where it equals to 1. This looks exactly the same as my right hand side. Sorry, out of focus. There we go. Therefore, left hand side equals to right hand side. Okay, let's continue. This one over here, I've included a grade 12 double angle. I have a double angle over here and I need to equal it to this. Now with your double angle, you get to choose which one of those three you're going to be using, okay? Choose them very carefully and wisely. You're allowed to use any of them anytime, but you don't want to be walking around in circles with this particular question. So if you see a plus one, I made you guys write this down in your book. If you see a plus one, on the left hand side and there's no one on the right hand side, then you know that you want to eliminate that one, so you're going to use the identity that has a negative one in it, and vice versa. If there was a negative one and you want to eliminate it, you're going to use the identity that goes 1 minus, I think it's 1 minus 2 sine squared x or theta, right? And if there's no numbers in there, then I'm going to suggest you use the cos squared minus sine squared x, which is exactly what I did over here. And then I noticed that this here was difference of two squares, so see 1 minus 1 plus, and I noticed that this whole denominator and this here can cancel out, leaving me with just cos x plus sine x. Right, and that happened to be my right hand side. So left hand side equals to right hand side. Okay, another example. This one over here. Oops. This one over here has a special angle in it. I didn't mention special angles yet, but I told you guys in class when you're doing special angles, you can use the special angle diagram. Ooh, let's clear my page. Just call the unit circle, this one over here, or you can type it in on your calculator. The one that we can catch you out for is 10 of 30 degrees. Please be very careful with that. Some people use, I think there's a method where you can use on your fingers, a nice way to remember. Other people use the table thing where they remember it. Other people use triangles. Whatever it is, that is perfectly fine. You are allowed to use any of those. Anyway, this here happens to be, I'm working now with my left hand side. My left hand side happens to be a compound angle, right? If it's a compound angle, this is what it opens up to using the identity, right? And there was a multiplication, so I put them into two separate brackets. This part here is also a compound angle. It opens up to this over here, right? Then I noticed this is a, what I then did was I noticed there's a negative here, a positive here, exactly the same things over there. Therefore, it's the opposite of difference of two squares, right? Alternatively, what you could do is jump to the step where you put in the special angles, what they actually work out to, and use FOIL, right? Anyway, there's what the special angle works out to. There's what the special angle works out to. And I simplified it. I got 2 over 4. this here. I typed it in on the calculator, or you can just see root 2 squared. There we go. 4 squared. There we go. I see that this and this are a common term, so I take it out, right? It's simplified. What goes into 2 and into 4? 2 goes into 2 once and into 4 twice. And I'm left with this part over here. This looks familiar. It's the double angle identity for cos. So therefore this is what it looks like. And I just put it over the denominator of 2 so that it looks like my right hand side. Left hand side equals right hand side. That's all that you really need to know.